Building a document agent that works is easy in theory. You pipe a PDF into a text splitter, embed the chunks, throw them into a vector store, and call it a day. You see, most developers treat the ingestion layer of a system as a pre-processing detail rather than the foundation it actually is. How you extract and chunk a document decides what your vector store contains. And if the structure got destroyed before retrieval ever ran, no amount of prompt engineering fixes that. Technically speaking, the ingestion layer is responsible for three things: extraction, getting text, tables, images, and structure out of raw documents; chunking, deciding how to split that extracted content into retrievable units; and enrichment, attaching metadata and context that makes retrieval precise. Most developers only think about chunking, but every chunk you create is a retrieval unit. If the answer to a question lives across two chunks and retrieval only surfaces one of them, the model fills in the gap with whatever it has. To avoid this issue, several ingestion patterns have surfaced over time. Here's what they are and when to use them. Pattern 1. Naive fixed size chunking. This is where almost everyone starts, and it's worth understanding exactly what it does and doesn't do. You take the document text, move a sliding window of n tokens across it, and every n tokens you cut. That's the entire mechanism. The splitter has no awareness of what it's doing to the content. It doesn't know it just cut a sentence in half. It doesn't know it separated a table header from its rows or split a clause from the paragraph it was referencing. Pattern 2, recursive/structure aware chunking. Instead of cutting every n tokens regardless of what's there, you define a hierarchy of separators. Paragraphs first, then sentences, then tokens. You only drop to a smaller separator when a chunk would exceed your size limit. Paragraphs stay intact when they're short enough. Sentences only get broken as a last resort. Related content stays together. This is exactly what LangChain's recursive character text splitter does by default, and for most general-purpose document work, it's the right place to start. Pattern 3, semantic chunking. This one is different in kind, not just degree. The first two patterns use syntax as a signal for where to cut. Semantic chunking uses meaning instead. You embed every sentence in the document. You compute the cosine similarity between each consecutive pair of sentence embeddings. And wherever that similarity drops sharply, you place a chunk boundary. The result is that chunk boundaries follow the document's actual topic shifts rather than its formatting. Pattern 4, hierarchical/parent-child chunking. There's a tension in chunking that every developer hits eventually, and it's worth being explicit about it. Small chunks are better for retrieval. They match queries precisely, they're specific, they surface the right passage. But small chunks are worse for generation. The model gets a narrow slice of context and lacks the surrounding information it needs to reason accurately. Large chunks are the opposite. Better context at generation time, worse precision at retrieval time. You can't resolve this tension by picking a chunk size. You resolve it by indexing at two granularities simultaneously. That's hierarchical chunking. Pattern 5, layout-aware/structure. First, parsing. Everything up to this point has made an assumption that isn't true for a large category of real documents. It's assumed that if you extract text from a document and read it sequentially, it makes sense. That the words come out in an order that reflects the document's actual meaning. PDF documents are often not like this. A two-column academic paper parsed left to right across columns becomes incoherent word soup. You're interleaving sentences from two completely separate columns. Layout-aware parsing deals with this before chunking even begins. Using layout detection models, much like or multimodal vision language models that process the document as an image, you extract not just the text but the structural understanding of the page. Then you chunk against that extracted structure, not against the raw linearized text. Pattern 6, enriched contextual ingestion. This pattern doesn't change how you chunk. It changes what a chunk actually is. A chunk isn't just a piece of text, it's a retrievable unit. And retrieval based purely on semantic similarity has a fundamental blind spot. It has no sense of provenance. It can't distinguish this year's contract from last year's. It can't tell a superseded policy from a current one. It treats an archived document the same as a live one, as long as the text looks semantically similar. And in document corpora, old and new versions of the same document look very similar indeed. Metadata-enriched ingestion means treating every chunk as a structured record with fields attached. Whatever dimensions your agent will ever need to filter or rank on, these fields get attached at ingestion time and used at query time to scope retrieval before semantic search even runs. Pattern 7, agentic/adaptive ingestion. All 6 patterns above share one assumption. You pick a strategy and apply it uniformly across your entire document corpus. That assumption breaks when your corpus is heterogeneous. When one pipeline needs to handle research papers and invoices and legal contracts and internal memos, documents that are structurally completely different from each other, no single fixed strategy is optimal for all of them. You are always over-engineering for some documents and under-engineering for others. Adaptive ingestion solves this by adding a routing step before processing. An agent or classifier analyzes each incoming document and selects the appropriate strategy. This is the current frontier of document ingestion. Increasingly viable in 2026 with multimodal models doing the routing, but still partially experimental at scale. These patterns aren't a checklist, they're a progression, and each one builds on what came before. The ingestion layer is where document agents win or lose. Every retrieval failure, every wrong answer, almost all of them trace back to an ingestion decision that didn't match the document type. Fix the ingestion layer first, everything downstream gets better.